Look at these numbers here, which are in that left box. 5, 10, 15, 20. There's a pattern. Tell people at your table, what is it? Okay, you're brilliant. Yes, plus 5. Go ahead and write it down so you see it. It's adding 5 every time, which I hope reminds you of a linear function because it has a constant rate of change. Okay, that's the first kind of sequence we're talking about today. Kind of like this. The second kind, look at the box to the right. 1, 5, 25, 125. Tell your table, what's the pattern?
5 times 5.
Okay, it's multiplying. Good. By 5. Every time. We got two kinds of sequences. Sequences are simply a list of numbers that happen because there is a constant pattern. So here's your definition of a sequence. It's literally just an ordered list of numbers, or you could say a list of numbers, but I'll say ordered. A term is a number in the sequence. So I just showed you two examples of sequences. There's another example in the top right here, 5, 10, 15, 20, 25. It's actually the same one. The first term is 5. The second term is 10. The third term is 15. The fourth term is 20. The fifth term is 25. It's just what order it's in. Okay, here's what I need you to know about arithmetic sequences. We're going to write several things in this box. I need you to have them all. An arithmetic sequence, no, I did not make up that word. Someone did. It wasn't me. An arithmetic sequence, you're going to see Monday and Tuesday. We note it with this A and then a little n, subscript. That's what that's called. Just so you're aware, next week, Monday, Tuesday, you'll see that for an arithmetic sequence. Today, what I need you to know is that it's going to add or subtract by a constant amount. So like this one added 5 every time, which means that this is really important. It is linear. Arithmetic sequences are linear because they have a constant rate of change. So this one has we don't call it slope because it's a sequence, but it has a slope of 5 over 1. And then we talked about this word last week. Today you're going to use it. Arithmetic sequences have a common difference because if you subtract any two numbers, it's going to give you the same amount every time. So 10 minus 5 is 5. 15 minus 10 is 5. That's arithmetic. Geometric, as you saw, multiplies, right? Geometric sequences, we note with a G and then a little n. They don't add or subtract. What do? Multiply. Which I hope reminds you of what kind of function that we've been talking about for 3 weeks? Exponential. An exponential function multiplies because that's what exponents do. So this one's multiplying by 5. The word that you're going to Okay, it's multiplying by, Addison, what is it multiplying by? Multiplying by half. I know it's dividing by 2, but please don't tell me dividing by 2. So go ahead and write in the pattern. Since it's multiplying, it is geometric. You need to tell me that it has a common ratio. And you said it in your, what you're multiplying by, your common ratio equals 1/2. That's what you're multiplying. The next number, if you multiply by half again, 7.5 or 7.5. So give me the next number. 18. Talk to your table. What's the pattern? Okay, Ari, can you tell us please what's happening? Right. 4 plus 5 plus 6. So each time it's adding one more. Guys, it's adding. Is it adding the same amount every time? No. So is it a constant rate of change? No. Don't tell me it's arithmetic. It's not. This is neither. It's a cute, nice little pattern, but it's not arithmetic because it's not the same amount every time. But you could continue your pattern if you like. Plus 7 to get the next number. So the next number is 24. This is neither. If you see one like this, it's a nice little pattern. It's not arithmetic. Please don't get fooled. Andrew, what's the pattern?
For what number?
Number 3.
Minus 4.
It's subtracting 4 every time. So, Kurt, what is it? Okay, it's a common difference. Since it has a common difference of -4, Aiden, would I say this is arithmetic or geometric? Is it multiplying? It's subtracting. So what's it going to be? Arithmetic. Let's get the next number. If you subtract 4 again, your next number is good. Number 4, -3, -12, -48, -192. It's multiplying by something. By 4. So it is arithmetic or geometric? Geometric. It has a common ratio of 4. And if you take -192 and you multiply by 4, you get -768. You have 32, 16, 8, 4, and 2. Rachel, what's the pattern, do you think? Jordan, what's the pattern?
Pattern is 1/2.
Yep. It's multiplying, so you have a common, here's your common ratio. Since it's multiplying, what do we call it? Geometric. And by the way, I need us to see this. We said that geometric sequences are like exponential functions. If you connect these dots, it should look familiar to you. Look at it. That's an exponential function right there. It's curved, just like the ones you've been graphing, because it's multiplying by a common ratio. If you were to connect the next ones, oh my goodness, what's it make? A line. So is it going to be arithmetic or geometric? It's going to be arithmetic because it's linear. Yeah. But it is also the common difference. What's it subtracting by? 3. 3. -3. So since it's subtracting. Arithmetic, it's adding 2. Okay. So I'm going to make a table of these values. Since it's arithmetic, these are my terms, 4, 6, 8, 10. N stands for the term number. First term, second term, third term, fourth term. You can graph these terms as points. So take this right here and graph the point 1, 4. Then graph 2, 6, 3, 8, and 4, 10. Don't connect them. It's a sequence, not a line. I know it makes the shape of a line, but we don't want to connect them. Look at your next sequence, 1, 2, 4, 8. Arithmetic or geometric. Geometric is multiplying by 2. So it should be the shape of kind of like an exponential. Just don't connect the points. So I should see you make a table for me. N and G of N. Can you please go ahead and do that one and then check it with me when you're done. Try the last one. It's geometric because it multiplies by 2. N just stands for your term number, so you have 1, 2, 3, 4 terms. Notice how it's kind of curved when you're done because it's an exponential function. The first is 1, the second is 2, third is 4, fourth is 8.